Hello, my name is Hein Weber-Kentor and I'm a Senior Solutions Engineer at Kaminario. Today I will demonstrate a VM backup and restore using the Kaminario K2 and Commvault IntelliSnap integration. This integration is based on Kaminario K2's native snapshots, creating either an application-consistent full or incremental backups in both physical and virtual environments, including applications like SQL, Oracle, and so on. The data to be backed up is copied from the K2 snapshot without affecting the production virtual machine's availability or performance. The demo environment includes a 2012 R2 Windows VM as the ComServe, installed with version 11 SP10, a K2 storage library which is located on a 1K block K2 system. The media agent is an ESXi server within our cluster, and the backed up client is a Linux 7 64-bit VM. The VMFS is located on a data store called 589 Commvault DS1, which is a volume in the K2. Under the K2 Snapshot Objects tab, using Kaminario vCenter plugin, we can see the snapshots that were created for this data store, including the K2 snapshots taken by Commvault, indicating when the backups were performed. We can arrange the snapshots by creation time and see the latest snapshot to be created by Commvault by the job ID prefix. Let's head over to our Commvault Simpana. We will locate our vCenter and the subclient for VMware, called VSA_VM. In the subclient properties, we can see the content for this backup is the Commvault Backup 01 virtual machine, which is being protected by the IntelliSnap storage policy. The proxy for the IntelliSnap operation is Sol SRv01, which is an ESXi within our cluster. We can see that the IntelliSnap is enabled and the Kaminario Snap engine is selected, as well as the backup is application consistent. Make sure that the Enable Backup Copy is checked in order to enable the snapshot copy to the storage library. Prior to the backup, I created a new file in the VM named File1. In a later phase, we'll verify that this file exists once the VM will be restored. To take a new snapshot backup, we right-click the subclient and select Backup. The selected backup type is incremental, and the backup copy to the K2 storage library will start immediately after the snapshot creation in the K2 all-flash array. As IntelliSnap also interacts with VMware itself, once the backup job is successfully committed, VM snapshot will be created for the selected VM. Then the K2 application consistent snapshot is created, and the VM snapshot can be removed. The K2 snapshot will be retained based on the retention policy as defined in the snap copy properties. Note that the job ID is used in the K2 snapshot name prefix. Once the snap backup is done, the backup copy job starts. In the Virtual Machine Summary tab, the custom attributes have been set, and we can see when the last backup was. Furthermore, if we go to our data store listing, we can see the latest snapshot that was just created. We can also see that a K2 view was created from that snapshot. The view is then mapped to the relevant proxy and the backup begins. The data is backed up from the K2 view to the configured K2 storage library, so there is no impact on the production VM. Once the backup is complete, the K2 view will be unmapped and deleted. Now we'll go ahead and shut down the VM and accidentally or not delete it from disk. This VM was configured on top of a K2 volume. Since our VM is protected by Commvault IntelliSnap and was located on a K2, we can go ahead and restore it from the snapshot backup we just created. In Commvault Simpana, navigate to the subclient, right-click and select Browse and Restore. Here it's possible to restore several types of objects. We'll choose the full virtual machine option. We'll use the latest snapshot backup. Let's view the content from that backup. You can see that we have only the Commvault Backup 01 VM in this backup, with a variety of files, its VMDK, logs and VMX files. As we want to restore the entire virtual machine, I will choose Recover All Files. We will restore in place and will power it on once restored. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . We can see that the restore operation started. A K2 view is then created for the specific snapshot and provisioned to the relevant ES6 proxy. The ES6 will rescan it, and its name will be changed to the name of the backed up data store plus a suffix of gx_backup and the job ID. The virtual machine will be registered from that snapshot, and data will be copied from the snapshot data store to the original data store. We can see that the VM was registered and restored to its original location. The old VM placeholder has been removed. The K2 view was unmapped and deleted once the restore job was completed, and that the new VM has been powered on and fully recovered. To summarize, this was a demonstration of a virtual machine backup and restore using the Kaminario K2 snapshot integration with Commvault IntelliSnap. This built-in automated, efficient, app-consistent backup and recovery supports the organizational data protection strategy and can easily be leveraged for SaaS needs such as production and non-production copies or dev test environments. For further details, please visit the Kaminario website. Thanks for watching.